Thank you very much for your patience. We are ready to start. Just want to say a couple of words about our special guest. As you've seen on the flyer, Professor Gerard was awarded the Nobel Prize for Physics in 1999. And this is just one of the many recognitions he got for his groundbreaking results. And I think it's really important to stress it. It's not about the recognition, it's about what he left us. Without him, with our understanding of the fundamental laws of nature would be much, much more limited. I don't want to go into too many details because we're already late, but it really revolutionized the way we understand quantum field theory, and which is the way we understand the law that regulates fundamental particles. So it really gave a huge impact in the field of theoretical physics. And he also has a huge impact of popularizing science. For instance, he has, and also not only popularizing science, but spreading science for large audiences. He has a series of advices on his website on how to be a good theoretical physicist, and I try to follow them. It's very difficult, but I read them when I was a student, and I found them inspiring. I try to follow them. I do my best. As I said, it's very difficult, and I hope that today we'll be able to inspire some of you as well. So thank you very much for being here, and please welcome Professor Gerard.
Thank you very much, everyone, for your kindness and the introductions I've received. I'm also happy to see a nearly full room of enthusiastic listeners. I hope I can bring forward a little bit the beautiful things that modern science has brought about in many ways. We had a meeting in Campania and about very deep and important scientific features that we all try to understand better than we do now, and we think we're very slowly making progress. I don't know how fast that will go, but every now and then the question arises, why is that so good for us? What will it change, and what should we be looking forward to? And actually I thought, well, there is a booklet which was printed a few decades ago, where I expressed my ideas about what is all this science good for, what can we learn, and how can it change the human society. And I found lots of changes could take place if we want to, but very much it depends on factors that I certainly don't have under control. So nobody knows where all this will go to. So there are certainly very many questions, among which is will computers, and notably quantum computers, cause landslides in human societies? And I think the answer will be yes, but that we will also find from the other questions I have to ask. The other question is, will computers take over? One of these days, one might suspect that humanity will not be under control of computers anymore. The computers will be controlling us, and where that will lead is very difficult to predict at all by anybody. So, will robots take over our jobs? That's what many people are concerned about. I actually think not, but there are all sorts of little things between parentheses put after that. And then also the question which somehow interests me terribly much is the question whether we will be able to live on the moon, not only go there and return, but establish a thriving, lasting human presence on the moon, and such that the moon is simply just an outskirt of our home place, which is planet Earth. And that holds for the moon, but doesn't hold for other planets as well. What about colonies on the moon? So, and what about colonies on Saturn's ring? Saturn's ring, I have a special place in my heart because there are such beautiful photos which have been sent to Earth by a spacecraft called Cassini, and that spacecraft has sent many beautiful pictures of Saturn. I would love to see human colonies arise there, but I don't know whether anything like that will be possible. So, and you can have even more daring ideas about the future, whether the human culture, human societies will manage to extend beyond the solar system to other stars. That question I can answer right away. The answer is probably not in the foreseeable future. We don't know how long that will take. So, next question, which I mentioned already, is which other science revolutions will take place to affect our culture? Besides the computers, there will be lots of things, but we'll have to wait and see. Or will there be devastating wars, terminating human existence? Also, that is a possibility that some people have been thinking about. How safe are we on planet Earth? Will there be new developments? I think all these questions are very important, and we do not know which future turns history will make. Indeed, I do believe that our lives will be affected by science in a very big way, and the extent to which these changes will happen or will not happen, that is very, very difficult to predict. So, I just want to show how much science can do for us, in particular, explain the past. We are not so good in predicting the future, we are much better in predicting the past. And predicting the past means what was the distant past of our world like. And here I have made a little list of what happened in the distant past. Well, let's begin with the beginning. 13.8 billion years ago, the whole universe got started by just something like one single point exploding and generating a universe that started out very small, but very rapidly expanded to become as large as the universe is today. About these initial stages, science has a lot to say. Also, these things that could be said about science, by science, have been discussed in the Campania meeting that just ended yesterday. The Earth itself came into being much later. It's only 4.5 billion years ago. And if you compare those two numbers, here and here and here, you see that, or here and here, you see that the 2/3 of the Big Bang expanded without having any planet Earth anywhere. Planet Earth had not yet formed. Planet Earth formed roughly 4.5 billion years ago. And but then, and this is not so well known in the human society because science is not totally sure about this, but most scientists have good reasons to believe that about 4.4 billion years ago, a big collision took place between Earth and another planet. You can imagine how that could look. That would be a terrible event indeed. And that other planet then shocked the Earth to such an extent that anything that could ever have lived out there would die immediately, instantly almost, by such a violent collision. But the scientists have good reasons to assume that this happens anyway, because they have a lot of evidence from the past. For instance, they looked at the occurrence of nuclear isotopes in the crust of the Earth and compared that with nuclear isotopes on the Moon. And they find that they are almost identical. The ratio of their existence is almost identical on Earth as on the Moon. And that is a very strong indication for most scientists to believe that the Moon and the Earth and the top mantle of the Earth have the same origin. it was this other planet which collided with the Earth. That planet was given a name, it's called Theia. And after it collided, things didn't tidy up so easily, but all the debris of the collision went back into space and formed a big ring. And after that, planet Earth probably had a system of rings which would be more conspicuous than now Saturn. Our whole Earth would very much look like the way the planet Saturn looks today to us. The planet Saturn hasn't always looked like this. These rings have been fainter in the distant past, and they will become fainter in the future. But right now, planet Saturn is certainly the champion of rings today. But in the older times, for a while, Earth was the champion in having rings. So this planet was given a name, but eventually what happened was all of matter went back into space, didn't fly far away, but stayed at some distance from the Earth and formed these rings debris. But then eventually these particles that formed rings made the whole set of rings unstable. So parts of the rings approach each other, formed little moonlets. So after a couple of millions of years, the Earth is no longer surrounded by a set of rings, but by a set of little moons. And then after some more time, the little moons came together and they formed the moon as it is now. But by rotating faster than the orbital velocity of this fresh moon, the fresh moon was forced to move away from Earth. It came so far away after a while that it's now something like more over than 400,000 kilometers from the Earth. Now the moon looks as a peaceful thing in the sky, not much affecting our lives, in spite of what people think. It doesn't do very much. But in the past, when the moon was as close to the Earth as just a couple of diameters of the Earth, that was such a powerful effect that it caused a tremendous change of conditions on the Earth, because the moon is the cause of tides. Now, if you put the moon a factor 10 further away than it is now, the power of the tides is a factor 1,000 less. So if you go back in time and you put the moon at 1/10 of the distance as it is now, the tidal forces will be gigantic. They will be 1,000 times stronger than the tidal forces today. And this must have a very strong effect on anything that happened on the moon. You know, I'm sorry I'm deviating a little bit from my original questions, but I find it so fascinating as a scientific find that I had to mention this thing. But again, if we wait a billion years or so, something very important happened. It was still some 3.7 billion years ago, much less than 13.8 times a billion years, but still long ago, the first evidence of life forms must have lived there. So we had some idea that there was life around that time. So what happens during these billion years, we don't know exactly, but there are all sorts of theories how this life could have originated. And so this was this collision. The idea is now that something must have triggered something else to make life forms on the Earth. What was that? And now I talk to my colleagues in biology. What do they know about the origin of life? In fact, they know a lot about what can happen and what cannot have happened. For instance, they don't know exactly where life formed first. Originally, the theory was, well, with all these tidal forces on the Earth, there must be a lot of little ponds, they're called tidal ponds, or tidal region, tidal ponds is the only word I can think of now. These ponds were each different, and they may have carried molecules of all sorts. Some of these molecules were very complex. Now, originally, there was no reason for the Earth to carry such complex molecules, but They add these elements, the red and blue and black and white elements, and add to that lightning from the many storms and heat and temperature changes on the Earth. So then you can easily imagine that more complicated molecules formed. Somehow these molecules must have generated life. And how did it go? Some people then talk about the first things of which they found evidence, that is that life was forming cells. And these molecules form cells, and the cells are the first living things. But that cannot have been the precise origin of life. The reason is these cells, with all the organisms inside, are far too complicated to have formed by chance. That simply doesn't happen. So in the beginning, there were no cells, they were just molecules which looked a little bit like molecules in living tissues today. These molecules may have entered into a period where there was a notion of survival of the fittest, of separation, of differentiation of the cells, and some cells were more lucky in the way they were living in these tidal ponds than other cells. So, what's happening? Yes. So what these molecules then first did. No, I should go back one step further. Hey. This is where I want to lead. These molecules entered, well, they were very inefficient in reproduction. There was practically no reproduction. Cells formed and cells disappeared. And some cells originated in more favorable conditions than others. And some of these cells entered in such a way into these ponds that they could reproduce themselves. How exactly that is gone is a big mystery. But biologists do know that a molecule exists that favors the phenomenon of reproduction very, very well. These are called DNA and RNA molecules. I won't bother you with all the properties of these molecules, except one important thing. These molecules form long chains of proteins which together form these molecules. And these molecules, they behaved in a very complicated way, but in such a way that they stimulated reproduction. And reproduction really means that not only these molecules were able to produce more DNA and RNA molecules, but there's other DNA and RNA molecules got the same shape. And that is very amazing that this happened. And how exactly this happened, biologists don't know. But at least there are some ideas about how this could have happened. That is DNA and RNA molecules somehow underwent chemical transitions such a way that a single molecule could change into a doublet of these molecules, which had the exact same amount of information in them than before. This is a very important moment in life, and I think that marks the real beginning of living tissues. Not only reproduction, the other feature that they must somehow have taken care of is to metabolize. So metabolic forces and phenomena must also have been taking place. So DNA molecules literally ate other molecules, such as to grow larger. And how that exactly happened, the biologists do not know, but they know a lot more about it than I do. So I should stop talking about that. But what you then see is something very interesting. So we have a life consisting only of molecules eating other molecules and changing into more of these molecules, and some molecules that reproduce themselves. From that, we have to have a second transition. And these molecules must have realized that at some point they were very weak. A molecule could be eaten by another molecule very quickly. So the best molecules in the system were the molecules which could do something about this. And what they may have done is they started to grow a little bubble around them. A bubble is what we now call a membrane of different chemical substances which form literally foam. and those molecules started to live inside the foam, and that way they were a little bit better protected against enemy molecules somewhere else. So this was a defense act to form a bubble around you, but this way, this made the whole thing, living thing, look more like a living cell than before. This is the prokaryotic cell, but then the eukaryotic cells contain not only molecules in this big thing, but those molecules themselves were again surrounded by a membrane, and then they had molecules inside. So the thing became more and more complicated, and this now is what scientists are still fairly certain about, because they now see a chain of events that must have taken place later. And when they investigate life as we see it today, we see that the more advanced forms of life are built out of these kinds of cells, and then you can extrapolate from there. What happens when you extrapolate from there? Well, the one thing is these cells decide to collaborate. When many cells have been produced by the same reproductive action of the original cells, then they might hang together for a while and form what we call multicellular features, things. Are they alive? Well, in a very rough sense, perhaps, but the question was, of course, whether these things would reproduce themselves again. And somehow this happened, and then you get multicellular life. So now things became more interesting, but these multicellular lives, living things, again found themselves to be a little bit unstable, and there are dangers for all directions. Other cells might attack them. So they wanted something stronger than a bubble to protect themselves. So they found, after billions of years, perhaps, they found that you could take little pieces of chalk, glue them on your membrane to get something stronger than that. And so you get living tissues with a kind of shells surrounding them. And the oldest shells were something like 500 million years ago. And so that was another step in the evolution of life. So having now living tissues which protected themselves with hard material so that they could be, so if whenever the water went away and they would be on dry ground, they wouldn't evaporate immediately. They would survive that until a next wave of water came to help them again. By the way, the theory of the tidal ponds is not the only theory. Another theory was that there might have been not only tidal ponds, but also something similar happening on the sea floor. On the floor of the oceans, there were vents which emit very, very hot water. And in this hot water, you have, of course, temperature also playing a role. And maybe for all these chemical reactions, having temperature differences was also very important. So maybe this whole story was correct, but only you have to replace the tidal ponds by vents inside the deepest parts of the oceans. Or maybe a combination of the two. Maybe there were tidal ponds which contain hot water. Maybe that's where things happened. We don't know those details at all, but maybe one day science will find out. I'm very curious in what they will find. I can recommend anybody who wants to know more about this in biology. That is the book by Richard Dawkins. It's called The Selfish Gene. Dawkins emphasized that if you look at living creatures today, you find that they have in them chromosomes. Chromosomes are combinations of DNA and RNA molecules, and they contain the inheritable material now written in a very stable form inside the cells of living creatures. And these pieces of data in these chromosomes are called genes. A gene is a very small part of a chromosome which contains a little program. You can say a gene is a little computer program. It's amazing that such a thing could have resulted spontaneously after certain steps in the evolution tree of life. But that is probably what happened. And these genes managed to reproduce themselves in living matter to get more genes there. And if the matter which contained those genes if this living issue which contains those genes is more successful than the living tissues elsewhere, then this gene is having an advantage of being able to reproduce itself more efficiently than other genes, and this way new inheritable properties were transmitted from one cell to its progeny, the next cell. So Richard Dawkins describes all this, but I am not a biologist, I am a physicist. So I asked questions that he didn't ask, at least not in this book. Maybe he's asked the question by now, because I think it is very important that there were certain questions that he did not answer. He didn't even mention those questions. And the question I have is, how did this take place? What was the mechanism of the reproduction? And does it all go flawlessly? And I think the answer to that is, of course not. Nature just does things and things happen, but not because they are so good for the living tissue, but because this so happened by chance. The chance is a little bigger that A happened and not B, or perhaps there would be an even bigger chance that C happened, but the gene wasn't there. So the consequences of the genes in living tissue was very hazardous, very arbitrary. But on the average, there was still a thread of progress and improvement in the life forms that came next. So this is, but it's very interesting to read how he derives these things by looking at the chromosomes of living tissues, of successful tissues, and of particles or life forms that were not successful in life. He finds those keys in our understanding, and that for me was an eye-opener to see that you can analyze things this way. Now I'm going to skip enormous number of steps, because I could go on like this to go from seashells to reptiles, to fish, to mammals, to primates, and so on. Each step being higher in the evolutionary ladder than the grandfather, so to speak. So about 1 million years ago, something happened among these animals that were now living on the earth, and that something was that those animals are called primates. The primates are basically the collective name of monkeys and humans and everything else, and looks a little bit like that. But some of those monkeys lost their tails. They couldn't use those tails, so not much anymore. And what is more important, they started to talk. They make noises which mean something. And you can only use your own imagination how that went. That they started to bark or to make sounds, like the birds make sounds today. I think the birds have a big future on them, that the arbitrary sounds that birds make one day will become sounds that they will be able to recognize, and birds will talk to each other, but that hasn't happened yet. So you see that these monkeys, they began to talk, and they began to think, and they evolved further. And you all know where it ended. It ended with people today. Actually, it's not ending at all. The evolution is going on. People are continuously changing still, and our properties are changing as time goes on. But since you only have information about a few thousands of years that is very well documented, we don't see those changes with our eyes yet. They are too small to be noticeable, but changes do take place even in our own genomes. And again, these talking and thinking primates, they needed shelter, like the cells did before and the multicellular creatures did before. They needed shelter, and this way, by needing shelter, they've discovered the caves. And the cave is something you can live in. You first have the caves are not empty. There are bears and wolves and lions living in these caves, but you have to chase them out somehow, and then the cave is yours. And then you have an enormous advantage in protecting yourself against the hostile world outside. Unfortunately, there were not enough caves, so very soon no further caves were discovered by these, well, I call them now cavemen. So they had to give up the hope of finding more caves to live in. They had to do something else. And now you already know what I'm saying next. Doing something else meant they have to make houses. Again, the dominant life form was going to make houses, and they abandoned the caves after a while because the houses they could make themselves were much better than those cave dwellings they lived in before. So, and now with these houses, history doesn't end there. After a while, lots of cavemen have made lots of houses sitting near each other for better protection, of course. And so the houses became cities. They built a wall around the cities, and there you have the cities. And from the cities you go to countries and so on. So you see, what I want to mention here is the enormous amount of repetition of the way things evolve, how life evolves, how everything evolves in the world. We won't stop here with houses. We'll probably go to the next step, but nobody knows what that is. Well, countries can maybe perhaps form what's called allies to form larger countries. Like Europe is now a conglomeration of many countries, which then eventually became one country. So the steps to further unification, enlargement of the whole thing doesn't stop. But it does stop when you can't go from the Earth to any other configuration. So now the question is, where will we go from here? And then, of course, in the future, where are we going? So planet Earth becomes, as I said, too crowded. So are we going to now seek our refuge in other planets and other moons and perhaps other star systems? Well, the question is, of course, like in the theory of the evolution of life, will this be possible or not? And so will we be able to set up colonies on the moons and on the planets? And my claim is that this is quite possible under some circumstances, but quite impossible for other things. So for instance, the moon, as I already said, is possible because what you do need on the moon is you have to dig and to make a viable human colony on the moon, you have to make a very safe house on the moon and a hotel, whatever you call it, so that, and then the safest houses and hotels will be under the surface of the moon, by preference a few meters soil you need to protect yourself against the hazards from outer space, because outer space is quite hostile against the human presence. There are micrometeorites, there are larger meteorites. Those meteorites could ruin your house, so you need a few meters of soil above you to protect yourself against those meteorites. But you also want to protect yourself against radiation, because cosmic rays are plentiful on the moon, and we want to be also be safeguarded against those. Actually, you might ask, what about us on Earth? We can live on the surface of the Earth. Why do those dangers not threaten us? The reason is two. Actually, you can call it also one reason. The reason is we have an atmosphere. The atmosphere will burn 99% of all those meteorites which come at so small that when they go through the atmosphere with very high velocities, they'll burn up immediately and don't do any harm anymore. Every now and then a meteorite hits the ground. Well, unless someone must happen to be standing there. There's a famous example of someone who had parked his car there, and the car was then perforated by a meteorite. These things can happen, but they're very rare, so you don't have to worry about it. But on the moon, you should worry about these things, and so that's why I think you have to make your house under the ground. Now, that sounds very boring. So who wants to live in in a cellar all its life and never get out. Well, modern technology will certainly make life, or can make life very convenient and luxurious in those circumstances. We can make large screens of television views or whatever view you like to see outside you. You might get a view of things moving outside you. You might have permanent films shown around you. But the other thing that you need to do is you have to grow your own food. Not necessarily your own food, but you have to form a society of people who also know how to make food. And these things are already tried today, that how do you feed people who live on the moon? Well, you have to introduce not only people there, but also chickens and eggs and fish and other animals, perhaps pork later on. You want to add all these animals to form a food chain to make the food that people will eat. So that's called an ecosystem. You want to have an ecosystem of all the plants and vegetables, animals, and other creatures to feed the people and to give them their favorite food. You need energy, but remarkably, there is enough energy on the moon. There is solar energy. But watch out, the moon rotates much slower than the Earth. So in 2 weeks in succession, there will be sunshine, but after the next 2 weeks, it will be very dark on the moon. And so if you use solar energy, but of course you need to make batteries that hold the electric current generated by the sun for at least 2 weeks. But you know for sure that the next 2 weeks there will be sunshine again. So this is not so terrible. This is something that you can make, and you can make sure that life on the moon will be pleasant. I myself had tried to make a scenario of how this would happen in the future. I described that in the book which I mentioned that is coming out or has come out some time ago with Cambridge University Press, and it's called Playing with Planets. So I play with planets, and so I also had a game in mind on how this would go. And the first idea was that the first creatures on the moon are intelligent robots, not people, because people are too demanding. You can't feed them so well. The robots won't have any difficulty in hibernating if the sun is not shining, but for humans that's difficult. So the robots will be able to make houses of the kind that people want under the ground. But not only that, you want to earn the money, you want to get the cash to make such an extremely expensive adventure. And the one way to make cash is to make games. So that you, for instance, I was thinking of moon soccer. So having a football game on the moon, and you have robots which are the football players, and people on Earth having the joysticks to steer those robots. You can rent a robot on the moon, you play a game so that the moon will kick, and the question is who will win this game. You can earn some money, but you also have to pay lots of money to be able to participate in the game. But all this together will generate the cash needed to build something. Those same robots which kick against the ball and to score for whoever is holding the joysticks, those same robots will also at other moments in time be busy with completing this human shelter, this human house or hotel or whatever you call it, to make it interesting for people to live in. That was my scenario, but there were other people, some countrymen of mine had other ideas of this. They found the moon boring. Well, I can't blame them for that, because the moon may well be quite boring, but he wanted to do something like this on Mars. But Mars is much further away, and you can't play this robot game. By the way, I should have added that what makes the robot game on the moon very interesting is that it takes about 2.5 seconds for a signal to go from Earth to the moon and back. So when you kick against this with your robot, you kick against the soccer ball, but only 2.5 seconds later you see the result of this kick, where the ball is flowing, and then, it's in the wrong direction, because in the meantime these other robots have been moving. yes, that makes the game more interesting, I think. Anyway, this was the idea which I had in mind then, but it was not taken over. The young guys who wanted to do the same thing with Mars, they set up a company to make the Mars travelers, make it possible to generate the cash for this. But they had ideas which I couldn't follow about the finances, and eventually the plan faltered because they couldn't really generate the cash needed to get this plan going. But at least they made a start. They had an idea about how to go, and I think, my idea is somewhat simpler, and the moon is somewhat closer. Maybe it's easier to do the same thing there. Yes, what I say in this transparency is that changes in life forms, which in the past took millions or billions of years, in these days now take only 1 generation or less. So evolution goes now much faster than in the distant past. So you can ask science fiction what the science fiction authors think is going to happen, but most of them are not physicists, so they don't think like me, and they don't think like any physicist does. So often they come with resolutions which are fundamentally impossible, unfortunately so. But I wish science fiction authors had to have it right, but very often, I'm saying sorry, but this cannot happen. One thing that cannot happen, for instance, is that people, not only people, but any spaceship you like to build, cannot go faster than the speed of light. So the speed of light is an absolute limit for velocities. And even if you go with the speed of light, that is very, very difficult. It will be more conceivable that you can go about 1,000th or 1 millionth of the speed of light. Already that is very fast, but that is how fast a very fast vehicle in space can go. Otherwise, you simply need too much energy to transport a single human being anywhere. So modern science is not so much in favor of making human colonies in other star systems. Those other star systems are more than 4 light years away from us. So even going with the speed of light, it takes you 4 years. If you can only go with 1,000th of the speed of light, you need 4,000 years to reach the next star. People usually don't survive such long journeys unless, and then science fiction authors think about freezing your body in a very special machine and then wake you up 4,000 years later when you want to step in this new world. But the big problem then is that while you are asleep, cosmic rays might find you and they might kill all your cells one by one. But there are lots of cosmic rays in the universe. So I think even this solution is unlikely to be formed. And then they think about colonies on other planets, but a vast majority of planets is not of the type that humans can ever live on. Not only are the temperatures wrong and the size is wrong, small planets will still be possible if they are smaller or as big as the Earth. Then, in principle, you could live there if the temperature is also right. But it's very hard to find such planets in the neighborhood. There was a talk about this just the other day by one of the founders, or one of the first astronomers who discovered planets outside our solar system. It's very interesting finding of a scientist that there are other planets. But yes, they are there, but no, most of them are not inhabitable by humans. So that's a little problem that science fiction authors could not solve. And then there's a problem of the computers. Now here there's something remarkable going on. Most science fiction authors think that computers will be dumb and unintelligent, so that they'll never perform the complicated tasks that a human can do. I think quite the opposite is true. The future is bright for computers, much brighter than for humans. I think that computers will be very intelligent and not at all. Their intelligence is not limited by the human intelligence. They can go much further, be much smarter than we are. And my argument for that is that I have a little theorem. And that's a funny scientific theorem that I like to use to explain why I expect intelligence to be a race that computers will win in a big way. And that is this. The theorem goes that whenever a living organism is considered that can do some sort of task, it doesn't matter which task you ask the living organisms to do, but when they, in millions of years, they specialize in doing something special, then humans, after a while, realize that there's something that living creatures can do that we cannot do. For instance, to fly. For a long time, until the beginning of the 20th century, humans could not fly. There was no way you could fly because people tried very hard, but they failed. For instance, they understood that to fly you need wings. Then they looked at the birds. What the birds have is their feathers on their wings. So then people tried, maybe it's better to put feathers on our wings also. So airplanes perhaps need to be covered with feathers. It didn't work. What people did not yet know in those days was to make wings with which people can use their own force to fly. Those wings have to be at least 10 meters in diameter. The wingspan should be at least 10 meters. Then you have a chance, and even then you have to exercise hard to be able to stay in the air. But then in principle you can do it. So people learned how to fly, but very quickly they learned how to fly much better than any bird, any insect, or any flying squirrel, or any flying fish. Nothing in the biological world can now fly as well as humans. Humans are the only creatures that can fly outside our atmosphere. They can go into outer space and with their machines, and they can land them on other planets. No living creature can ever do that. So when you try to mimic a living creature, humans are at the winning side in most cases. Not only for flying, but also what I have here, the buildings. Humans can make higher buildings than any tree or whatever you have. You can make deeper tunnels. Our wings, I discussed already, but you can also make rockets. And also the human telescopes are much, much better than human eyes, because a telescope is a thing that is made by our science. So human science is outperforming biological creatures in a big way, by factors of 10, perhaps a factor of 1,000 or 1,000,000. Look at these telescopes, for instance. So that means that if you now ask, can we mimic intelligence? Biological intelligence exists. That's simply our brain. Our brain is to some extent intelligent. My claim is when we learn how to make intelligent things, and if you once understand the scientific principle of making intelligent devices, will outsmart the computers that we make will outsmart human people in a big way. And that is what I expect. Therefore, that's what I said in the beginning of this lecture, that artificial intelligent robots will win over the human intelligence in a big way. What will be the consequence of that? And I'm sure many of you asked that question, and I'm asking the question myself. I don't know. I hope the future intelligent machines will be intelligent enough to realize that they should not start a war with each other. That would be silly. That would not bring about the advantage that you want. So you should not go in war. I hope they'll realize that, but I'm not at all sure. Maybe they'll say, well, we're going to use our intelligence to outsmart other intelligences, and every now and then a little war will be needed to do that. I hope they will not come to that conclusion, but that we have to remain and see. So, so those robots will be irrational, and that's why I hope, as I said before, there won't be dangerous wars and battles. The most dangerous period will be a period between now and a few hundreds or thousands of years from now. Stephen Hawking has said the same thing, that we are entering a dangerous period between now and a couple of decades, or perhaps 100 or perhaps 1,000 years, because that's the time span needed, that some people think, to make intelligent computers. I think the time span is shorter, but I don't know how short. And so that's something we have to be very much worried about, that if we make intelligent computers, we have to do it the right way. And the hope is that intelligent computers will not fall in the wrong hands of people who are out for conquering the world in a big way. They might outsmart the intelligent computer. But that won't happen for very long. The computers will be the boss. And we'll have to ask computers not to make any war, because nobody will gain anything after a war that they could win, but nobody else. People need, the robots need no air to breathe. They can survive extreme heat and cold, and they only have very modest needs of energy or building material. So those computers will certainly be at a very advantageous position. I don't know how many of you will recognize this picture, what it is. The picture I have here. Well, I think many of you have seen this picture before, I'm sure. This is in detail Saturn's rings. I love those rings, as I said before, because you should be able in principle to land a spacecraft on these rings, and then you can put robots there, and the robots will have plenty of building material floating around of them in fixed positions in a very predictable way. They'll have to make strong walls so that collisions with these ring particles will not have serious effects, but it all looks very peaceful from this distance. So it looks as if a robot can easily land on these and form its own colony. But now it has the entire ring system of Saturn to its disposal to make enormously powerful colonies of ring robots. And this is just another little fantasy that one could toy with. This is Saturn seen from another angle. So I see how beautiful this planet is with its rings. And I love it, how these pictures have been sent down back to Earth by one robot that went quite near to Saturn to see all its moons and rings, and they produced marvelous pictures. So a Roman colony on a robot colony on the moon is something that I would love to see happening one day. So what I said here already, I mentioned there's one thing about ecosystems. I would like that the first ecosystem has been built, for instance, on the moon or on Saturn, is an AI ecosystem, artificial intelligence ecosystem. That is to say, make a whole class of robots, each having its own separate task, and altogether they can almost do anything that you want to make life possible for a robot. Those ecosystems don't have to be very sophisticated. You don't have to put gates around them to avoid any robot will escape or something like that. No, this is in principle rather easy. But you can also think about bio-ecosystems. Those are ecosystems where you copy the food chain on the earth, all the vegetables and animals and fish and whatever you have to make food will form a bio-ecosystem. And to make those is more difficult. You have to think of creating and maintaining a healthy environment for these plants and animals. You have to make sure that the atmosphere stays right, that there's enough water, and so on. So this is a lot harder, but eventually robots will be able to make such kinds of ecosystems. And then you can have the humans live in your hotel on the moon or wherever, and the ecosystem will feed the people who want to go there. And some people talk about terraforming. Terraforming is that you take an entire planet or moon and you add an atmosphere on that, or you change the atmosphere of it to be such that humans can live there without spacesuit and with air to breathe. I think that's very much more far-fetched than many of the ideas I mentioned before. It is extremely difficult to not only to put an atmosphere around a small planet, but to keep it there such that the lighter molecules don't escape. So that will be a very tough task, but who knows, it's not fundamentally impossible. So let's say in principle it's conceivable, but I don't see it happen very quickly. This is the fantasy that people then have. Colonies in space, who knows? These colonies will usually take the shape of a ring, so that you can think, or something or a cylinder, something that can rotate, because rotation generates artificial intelligence, artificial gravity. And you want artificial gravity if you want to have people there. Even the ecosystem might need some gravity to keep itself in the same shape as it is on Earth. So at some distant future, the inside of such rings will look something like this. This is a fantasy I just picked up from the web, and there are more such fantasies. But so my conclusion is that science itself will eventually be reserved for computer artificial intelligence. That's the idea that the computers will be more intelligent and forget fewer things than people. They also know what they want to remember and what they want to forget, and so they will be in a big advantageous position compared to humans. One of the big challenges will be that the computers will take over our science, and they will solve the questions that we are leaving wide open because we are too stupid to answer them. They'll say, no, you have to do it this and this and that way. And then the artificial intelligent computers will write their own textbook about the new physics that they are discovering that we have not been able to discover even in our most wildest dreams of how to solve the questions we have. So how will this end? Robots, as I said, will be far more sure to travel than for thousands of years, even to the nearest star. So as I said, for humans it's impossible. For robots it's possible. For robots to survive 1,000 years is probably not inconceivable. And so they can reach the other planets and the exoplanets and see where you can try to build an ecosystem. That would be extremely interesting to see that kind of thing happening. As soon as I said it here, these biosystems look like ours, I think ways will be found to get the humans there. Probably not by sending them there, but by breeding them there. To have artificial machines that breed the first human on the outside planets, and then we'll have a complete ecosystem, including even humans to enjoy them. That way, the human culture can actually expand and go from star to star, hop from star to star. Well, where will that hopping stop? It will stop probably when you reach the outskirts of the star system. The other star systems are themselves thousands or millions of light years away from each other. It's going to be much harder to make such journeys. So if this conquering an entire galaxy is unlikely, to say mildly, to make a step from one galaxy to the next will be almost impossible. So to conquer the entire universe, some science fiction books are about this. They have stories about species that have conquered entire parts of the universe, but that I don't see to happen, not even a million years from now. So that I can safely bet that that's not going to work. So don't worry. Planets of the kind that we are living on still have thousands or millions of years to live. This Earth is quite stable. It will look different after a while, but you'll be able, unless you make very stupid mistakes, humans will be able to populate the Earth for many thousands or millions of years. That's what I believe. And the universe itself is, of course, much, much older. The universe itself will live on for billions of years, as it has already lived in the past. So I think that is the end of my story. Thank you very much. I hope there will be